find yourself just stuck trying to solve something, but you don't even know where to start?
Yeah, like facing a huge puzzle.
Yeah.
All mixed up.
Exactly. And you're just wishing for that one little piece, that starting point, that feeling, kind of overwhelmed, wanting a clear path. That's where we're jumping in today.
Right, so today we're digging into some ideas from a module called Identifying the Research Problem and Variables.
Okay.
The goal really is to shine a light on that very first, absolutely critical stage in, well, any research, or honestly, anytime you're trying to make things better. How do we actually pin down and define the problem? And, what are the basic building blocks we need to get our heads around?
So your mission, if you stick with us, and we really hope you do, is to walk away with a much better grasp of how research questions actually get formed,
Yeah.
what makes a problem really worth, digging into,
Yeah.
and understanding those fundamental pieces, variables, as you called them. Think of it as building up your toolkit, becoming more savvy about how questions get asked and answered all around us.
Exactly. Becoming more informed.
Okay, let's unpack this. Where does identifying a research problem, where does that actually start?
Well, the source material puts it pretty directly. It often kicks off when you recognize something just isn't quite right.
Uh-huh.
It contrasts that with situations where, everything is fine. Suggesting our drive to solve problems comes from seeing a gap or a need, or maybe just something we don't fully get yet.
Right. People get interested when things aren't perfect.
Precisely. When there's a challenge or maybe a chance for things to be better.
That definitely rings true. I mean, if everything was perfect, why bother changing anything? But the world's full of issues, right? How do we zoom in on something we can actually, handle, something solvable?
That's a really critical point. The source definitely stresses finding a problem that's actually, well, addressable.
Okay.
It mentions leaning on insights from experts, people who really know their field, but also just carefully watching, observing the struggles people actually face day to day.
Ah, so like spotting patterns.
Yeah, spotting patterns, seeing where things could be improved. Think of like a doctor noticing a weird trend in symptoms, maybe. That could spark a whole research question.
So it's a mix then, existing knowledge and just being really aware of what's going on. And we're not just talking massive global crises here, are we? Little things count too.
Oh, absolutely. The material points out that problems aren't fixed. They evolve. What was a big deal years ago might fade, and new stuff constantly pops up.
Right.
Which is why, keeping up through professional groups, conferences, that's so vital. It's about constantly updating our map of what the current issues are.
Like staying current in any job, things are always shifting. And there's a really neat point in there about professional value. The source says identifying and solving problems, even small ones, is how we become valuable. That's quite insightful. It's kind of like any relationship, isn't it? Personal, professional. Figuring out the real issue is always step one to making things better.
Exactly. And then when we shift from just spotting problems to actually picking a research topic, the source brings in these two really important ideas: intellectual merit and practical merit.
Intellectual merit sounds a bit lofty academic. What's that really about?
Well, intellectual merit is about the academic value, the potential for real innovation. Does it add something new to what we know? Does it maybe challenge old ideas, push the boundaries a bit? In academia, yeah, that's often huge for getting funding, getting published. It's research that could really move our understanding forward.
Okay, I get that. The sort of new discovery angle. And then the other one, practical merit. What does that look like?
Practical merit is more about the real world impact, how immediately useful it might be. Will this research actually lead to things being done better? Can lots of people use it to solve actual problems?
Right.
Does it offer a chance for, relatively quick positive change, like finding a better way to get clean water somewhere that's high practical merit?
So ideally we want both, right? That sweet spot, something that's genuinely new and makes a real difference. But what if it leans one way more than the other?
Yeah, the source admits they don't always line up perfectly. You get trade-offs.
Okay.
Maybe something super innovative, academically fascinating, but the practical use isn't obvious right away. Or, flipped around, it tackles a really urgent, widespread need, but isn't maybe breaking new theoretical ground.
Yeah.
Both kinds matter, but the key is being able to clearly explain why this problem is worth tackling. Based on those two characteristics, you have to justify its significance.
That makes total sense. You need a solid case for why this deserves time and money, whether it's pushing knowledge forward or solving a pressing issue right now. Okay, so we found a problem, picked it.
Yeah.
How do we start shaping it up for actual research?
Right, that's where we get into developing the statement of the research problem.
Mm.
The source says this often starts really small, maybe just one single sentence nailing down the core focus.
One sentence. Wow, that's concise. But I guess it forces you to be laser focused from the get-go. What happens after that tiny statement?
Then you expand on it. You move to a more detailed explanation. Could be a paragraph, maybe even a couple of pages sometimes.
Okay.
The aim is to clearly lay out the research purpose, the specific questions you're trying to answer. And the source notes that sometimes, for longer statements, you might even include an abstract, like a mini summary up front.
So it's like building it out. Start with the core, then add the layers, the context, make the whole picture clearer. And how we say it matters, right? The source mentioned clear, simple language.
Absolutely critical. The source really stresses using straightforward, direct language. Avoid jargon, avoid overly complicated sentences.
Right.
The goal is clarity. Anyone reading it should easily grasp what you're trying to do, what problem you're tackling, and why it's important.
Okay, crystal clear, problem statement, check.
Yeah.
Now, here's where it gets really interesting, I think. The source starts talking about research hypotheses versus research questions versus research statements. What's the difference there?
Yeah, this is a super important distinction. So research hypotheses are more specific than just the statement. A hypothesis makes a direct claim, an assertion about the expected relationship between your variables.
Expected relationship.
That part's mandatory for a hypothesis, according to the source. It's not just wondering if there's a relationship. It's stating what you think it is.
Okay, expected relationship. Can you give me a solid example?
Sure. The source mentions things like expecting a, quote, strong positive relationship between divergent thinking and general IQ measure.
Uh-huh.
So the expectation there is positive correlation. As one goes up, the other goes up too. Or maybe stating that a new teaching method will lead to higher achievement than the old one. The expected relationship is that the new one's better.
Ah, okay. So a hypothesis is basically the researcher saying, here's what I think is going on between these things. It's like an educated guess, a prediction.
That's a great way to put it. It's a testable statement, usually based on some theory or prior knowledge. Research questions, though, are just questions.
Right.
They ask about relationships or effects, but they don't necessarily predict a specific outcome or direction.
So a research question might just be, what is the relationship between teaching method and achievement? Without saying you expect one to be better.
It's exactly that. And the source also quickly mentions statistical hypotheses versus research hypotheses. They're related, especially in quantitative stuff, but not quite the same thing. Statistical ones are set up specifically for the math tests.
Okay.
And it notes that in qualitative work, you might explore or develop hypotheses rather than testing them strictly statistically.
That's an interesting little side note. Okay, so the next big piece here is understanding variables. The source defines a variable as, well, basically anything that can have different values. Seems simple, but then it gets broken down quite a bit.
It does, and getting these types straight is just fundamental for setting up testable hypotheses and, designing good research. The source first contrasts variable with constant. A constant is something that stays the same for everyone in that specific study.
Right.
Like if you only study pro basketball players, then pro basketball player is a constant for that group, not a variable.
Got it. Makes sense. And then we get categorical versus numerical variables.
Right. Categorical, sometimes called qualitative, are about groups or types, like different car models, sedan, SUV, whatever, or maybe satisfaction levels, very satisfied, satisfied, not satisfied. Numerical or quantitative variables are where the numbers themselves actually mean something measurable or countable, like age in years or your score on a test.
And within numerical, there's discrete versus continuous. What's that difference?
Discrete variables can only be specific, separate values, usually whole numbers. Think number of mistakes on tests. You can have 1 mistake, 2 mistakes. You can't really have 1.7 mistakes.
Okay.
Continuous variables can be any value within a range. Like height in inches could be 68 inches, 68.2, 68.25. You have potentially infinite points in between.
Gotcha. Countable whole numbers versus potentially fractional ones. The source also threw in dichotomous variables. Sounds specific.
It is, but simple. Dichotomous just means a categorical variable with only 2 possible categories, like yes, no, male, female, pass, fail, often coded as 0 and 1 for analysis.
Okay, lots of ways to slice and dice these characteristics, but I think the really crucial one, for understand cause and effect anyway, is independent versus dependent variables.
Oh, absolutely. That's huge. The independent variable is the one you think influences or affects the other one, the dependent variable.
Right.
You can kind of think of the independent as the potential cause and the dependent as the potential effect. Researchers often change or just watch changes in the independent one to see what happens to the dependent one.
So back to the teaching example. The teaching method used that's independent. The students' test scores that's dependent. We're seeing how the method affects the school.
Exactly right. The source uses an analogy of something controlling or impacting something else. It's a good mental picture. Now the question becomes, how do we actually measure these things? Especially the fuzzier concepts, like, say, motivation or anxiety.
Which leads straight into operational definitions and measurement. This sounds like where we take those abstract ideas and make them concrete, measurable, turn them into data.
Precisely. Operationalization is that process, defining abstract things in really specific, measurable ways for this study. For quantitative work, yeah, that often means turning them into numbers. And that's where measurement instruments come in the tools. Surveys with rating scales, standardized tests, maybe structured observation checklists.
So if I want to study anxiety, I can't just vaguely talk about anxiety. I need to say, operationally, I'm measuring it using this specific anxiety questionnaire, which gives a score based on answers to these questions.
Perfect example. And the source points out, importantly, that the data we get is the result of that measurement. It might not be a perfect reflection of the whole underlying idea. There's always some potential error, some imperfection.
Right.
Which brings us to the really critical idea of the validity of the instrument.
Validity,
Yeah.
meaning does our tool actually measure what we think it's measuring?
Exactly. The source really stresses you need to justify why you chose that specific way to measure, that specific operational definition. Uses that great analogy, garbage in, garbage out. Yeah. If your tools are bad, if they don't really capture the thing you're interested in, then your data's junk, basically. And any conclusions you draw are shaky at best, like using a broken scale to weigh something.
Right. If you measure creativity using a memory test, your data isn't telling you about creativity. It all loops back to defining carefully and picking the right tools. So putting it all together now, what does this all mean for us?
It means that whole journey, from first noticing a problem to really nailing down the variables, it's all connected. It's foundational.
Okay.
A clear problem points you to the right variables. Those variables shape your questions, your hypotheses. And then to actually answer those, you have to think hard about how you'll operationalize and measure those variables accurately.
And for you listening, getting a handle on this process gives you a really powerful lens for looking at information you see every day. Whether it's a news report about a study or trying to figure out some work issue or even a personal problem, understanding how the problem was framed, what variables were looked at, helps you judge how solid the conclusions really are.
Exactly. It lets you ask those sharp questions. Was the problem clear? Were the right things measured well? Do the conclusions actually follow from how they studied the variables?
So here's something to chew on. Think about some challenge or problem you're dealing with right now, big or small. How might you start to define it like a researcher would?
Yeah.
What could be the key factors, the potential independent, dependent variables involved, and what challenges might pop up if you try to actually measure those things? Reflecting on how we frame the problem, like we've talked about, really does set the whole direction for the kinds of solutions we might even consider.